Welcome to this topic on 8051 microcontroller. Like in the previous videos, we discussed about 8085 and 8086 microprocessor. We are going to discuss here about microcontrollers. What is that difference between a microprocessor and a microcontroller? That as I will be describing you as we go along. Brief history of 8051 microcontroller. In 1981, Intel introduced an 8-bit microcontroller which is known as 8051. It is referred to as system on chip because it had 128 bytes of RAM. See here, there is a difference between your microprocessor and microcontroller here. The first very significant difference here itself, it's the system on chip, which is a very much an integral part of the microcontroller. Not like your microprocessor where you are not going to have any memory devices in the chip. Whereas microcontroller will have a memory inside it. This is a very important significant difference. As I told you, now moving to 8051. It has 128 bytes of RAM, 4 kilobyte of on-chip ROM, timers of 2, 1 serial port and 4 ports, all 8-bit. It means that it's an 8-bit microcontroller. All this put together in a one single chip. It has now become very popular. So, like Intel, many companies also started manufacturing different flavors or variants of 8051 with code compatible with 8051. What it means is that if you write a programming meant for 8051 for one particular vendor, means that same program will work for another vendor also. So leading to different versions with different speeds and number of on-chip RAM, because they all will be developed for different kinds of systems. So different kind of systems will have different data handling capability. That is why we are going to have different variants or versions of 8051. One of the few versions here is 8052 microcontroller, which has got all the standard features of 8051 microcontroller, as well as an extra 128 bytes of RAM and timer. It also has an 8 kilobytes of on-chip program ROM instead of 4K bytes. 8031 microcontroller and another member of 8051 family. This is also referred to as a ROM-less 8051. See, before 8051 came into the picture, 8031 was introduced. But you need to add an external ROM to it to use it. We call it as interfacing. So it's again a laborious process. In order to minimize that, 8051 came into the picture. So moving on, an 8051 microcontroller has certain features. They are 4 kilobytes of on-chip memory, program memory, we call it as ROM, 128 bytes of on-chip data memory, that we call it as RAM, 4 register banks, 128 user-defined software flags, 8-bit bidirectional data bus, 16-bit unidirectional address bus, 32 general purpose registers, each of 4-bit, 16-bit timers, usually 2, 3 internal and 2 external interrupts, 4 8-bit ports, 16-bit program counter and data pointer, and also certain special features like UART, analog and digital controllers, operational amplifiers. We'll be seeing that as and when we go along. The block diagram. See, this is just a block diagram of 8051, but actually speaking, there is an architectural block diagram also that is more important. But keeping the things simple, we start with the salient block diagram features. As you can see, you have different units like interrupt control, ROM, RAM, timers, serial port, input-output ports, bus and oscillators. The CPU of 8051 will be triggered by an oscillator that will make it That is what it gives the speed. And the CPU is also connected with interrupt control that will halt if there is anything outside the CPU. There are certain things to be serviced. And you have ROM, which is your program memory, RAM, as I told you, is a data memory, timers, buses, input output ports. That is, to and fro data can be moved between your microprocessor and your peripheral devices. And also you have serial port where serial bit communication is possible between your microprocessor and rest of the devices, TXD and RXD to name a few. Moving on. 8051 is a 40-pin microcontroller. You can see that it is starts from pin number 1 to pin number 40, and with there is a kind of a convex curve cut here. So P1.0 to P1.7 are your ports. RST is your reset. P3.0 to 3.7 is another kind of a ports, but you have a certain bidirectional functionality. That is, one port can have two functions. Crystal oscillators, pin number 18 to pin number 19, XTL2, XTL1. VSS is nothing but your ground function. Port number 2.0 to port number 2.7, that is pin number 21 to pin number 28, again is your address lines. Pin number 29 is program store enable. Pin number 30 again is your address latch enable or programmable. Pin number 31 again is external enable. And pin number 32 to 39 is port number 0.0 to 0.7, which is nothing but your multiplexed address data lines that starts with AD0 to AD7. It means it can also act as A0 to A7 or D0 to D7 at certain instances. And of course, they are your lower order address bus. A8 to A15 will be your higher order address bus. We'll talk about their ports and their functions now. The four ports, P0, P1, P2, P3, each use 8 pins, making them 8-bit ports. Well, upon reset, all these ports are configured as inputs, which are ready to be used as input ports. When first 0 is written to a port, it becomes an output. That is, port 0, whenever a 0 is written means it becomes an output port. Whenever you have 1 means where written as 1 means it becomes an input. It's because they are bidirectionals. Like I told you, port number 0 to port it is pin number 32 to 39 is port number 0. It can be 0.0, 0.1, 0.2 up to 0.7. 8 pins. It can be used as input and output. We have to have some resistor to make it work. That's why we connect port number 0 to 10k ohm pull-up resistors. It is also designated as AD0 to AD7. That is, it can be used as both address as well as data. In case of 8031, when we need to access the ROM, P0 will be used for both address and data bus. Address latch enable indicates it's a condition, that is P0 is either address or data. I told you like it can be used simultaneously, either way it can be used as an address bus or data bus. When ALE is equal to 0 means it becomes a data bus. When ALE is equal to 1 means it becomes an address bus. Port number 1 through 8, an 8-bit port which can be used as an input or output, which does not require any pull-up resistors because they are all internally connected. And you can be used to certain values. They can be used for use in programming. I have not mentioned any programming part because I am just going into the basics concepts of 8051. But you can use a programmatically we can code these ports to send the values between 55 and AA. Port number 2, port number 21 to 28, 8 pins, which can be used as input or output operations. Does not require any pull-up resistors. It can be used along with P0 to provide 16-bit address. So it is designated as A0 to A7. When 8051 is connected to an external memory, it provides a path for upper 8 bits of 16-bit address. It cannot be used as an input and output. Port number 3. It is also used of 8 bits and can be used as input and output. This can be provide some important signals P3.0 and 3.1, which is nothing but your serial transmitter receiver, RXT, that is receiver, TXT transmitter, collectively used for serial bit communication. Serial communication means one bit at a time it can be send data. 3.2 and 3.3 ports are used for external interrupts. 3.4 and 3.5 ports are used for timers T0 and T1. Port number 3.6 and 3.7 are used for write and read pins. They are active low pins. That is, whenever 0 is given to them, they will provide read and write operations to external ROM and 8031 base systems. Moving on. I told you about the dual roles of the ports. So when you talk about the dual role of port 0 and port 2, it is also designated as AD0 to AD7. It can be used for both data and address handling. While connecting 8051 to external memory, port can also provide both address and data. So the role of the 8051 is to multiplex both input as address or data in order to save the pins. Like that, there is a dual role for port 2 also. Port 2 also provides 16-bit address for external memory along with port 0. Port 2 is also designated as A8 to A15, where port 0 provides lower 8-bit data, that is A0 to A7. It can say that whenever an 8051 is connected to external ROM, which can be up to max 64 kilobytes, port 2 is used for upper 8-bit of 16-bit address. Then it can be used for external input-output. That is where the program code of external ROM can be addressed. It all depends on how your ports are going to be used. Thank you.